In this video, I'm going to prove the midpoint theorem and go over definitions for distances between points and between lines. The midpoint theorem says that if B is the midpoint of AC, then the segment AB is congruent to the segment BC. So let's go ahead and illustrate a picture of this to help us understand how to prove the theorem. We have a segment AC, and point B is the midpoint between A and C. So we have to prove that segment AB is congruent to segment BC. So it's given that B is the midpoint of segment AC, and that's going to be our first step, is to state that. Since B is the midpoint, by definition of midpoint, AB, the length AB, is equal to the length BC. And we know that if two segments are equal in length, then they're congruent. So, by definition of congruence, the segment AB is congruent to the segment BC. And that was what we set to prove. That if B is the midpoint of AC, then segment AB is congruent to segment BC. So the distance between a point and a line, where the point does not fall on the line, is the length of the segment perpendicular to the line from the point. And being perpendicular is the key here to finding the distance between the point and the line. If I give you some line, let's go ahead and call this line AB, and I put a point C somewhere that's not on this line, right here. The distance between this line AB and this point C is the length of a segment that is perpendicular to this line. So a line going this way would not be perpendicular. So I do not measure from C to this point here, because that is not the distance. If I tried going from C to point A, that also is not the distance from the line to the point, because the segment created between the point and the line needs to be perpendicular. So this segment C to some point we'll call X. So CX forms a perpendicular segment with AB because CX forms a right angle with AB. Now the distance between that point and the line would be the measurement of this segment CX. And that would be the distance between a point and a line. So if I had another point, let's say D, I would need to create a perpendicular segment, and then we would measure the length from D to Y, and that segment length would be the distance from D to the line AB. Now the distance between parallel lines is calculated by the distance between one of the lines and any point on the other line. So we know how to calculate distance between a point and a line. Now if we have two parallel lines, let's name this line AB and this line CD. I can pick any point on the line CD and find the distance between line AB and that point, X. And the way we do distance, remember, distance between a point and a line is the length of the perpendicular segment. We could also put any point on AB. Let's call that point Y. And measure from the point Y to the line CD. So that would be the length of the perpendicular segment between the point Y and the line CD. So the distance between parallel lines is the distance between one of the lines and any point on the other line. So you could place your point on either line and measure using the line that the point is not placed on. Remember, parallel lines will never intersect. That means the distance between the two lines is always the same. So this segment that we got measuring from AB to the point X is going to be congruent with the segment that we got from measuring from the point Y to the line CD, because we're parallel. And any other segment that is perpendicular between the two lines will also be congruent. This is known as equidistance. Equidistant, so being equidistant is where the distance measured along a perpendicular line between two lines is always the same, and this occurs between parallel lines. So if that distance is always the same, then those perpendicular segments are congruent. And this was just a quick introduction to calculating distances between points in a line and parallel lines.